In this question, what we're looking at is the idea that there's a deal where if you can make a purchase and pay it off over 2 years, but what we're looking at here is no repayments are needed for the first 3 months, and the interest rate is 18% per annum. What we've got is a $3,000 lounge being bought. So, what is owed after 3 months? Well, it's not a great way to buy something because you're not making any payments to start off with, but they're going to charge you interest still. So that's not really great, but what it would be worth. So the $3,000 is basically they you're owing $3,000, but it's getting charged 18% interest. So 18% per annum comes down to 1.5% per month. So that's where we get the 1 plus 1.5%. So the 1.015, and that's going to get charged for 3 months. So it's like compound interest. It's just getting more and more. Not a great way to do it. I wouldn't advise it, but this is how much it's owed after 3 months. Happy to leave it in that form. If you can put a monetary number on it and do the calculation, not a problem. But happy to see it left like that. The next part is we want to find the amount of each monthly repayment. Well, after 3 months, you start making repayments. So the fourth month is when you start to make repayments. But the amount that was there in the third month, after the first 3 months, is going to get interest charged on it again before you make a repayment. So we get a statement for the fourth month is at 3,000, the 1.015 to the power of 4, and then we minus m. After 5 months, well, what was in the fourth month is going to get interest charged on it again. So that's why it becomes 5. The m is to the power of 1, and then we make repayment again. That goes on for 2 years, so 24 months. So after 24 months, it starts to look like this. We've got the 3,000 times the 1.0125 has 24 amounts of interest being charged to it. But the first amount we didn't start paying for the first 3 months, so until the fourth month. So that's why it's only to the power of 20, to the power of 19, and so on, down to the last payment, which is minus m. So if you've been looking to do these via a formula, it's going to have a problem with this one, because your geometric progression is not going to be 24 there, but then 23 and then 22. It's because they've thrown just a little spanner in the works in the question to just throw it out. It's going to catch up people who are going to just use a formula. People who use a formula for this one will generally get it wrong because they won't get the correct amount of values here. Because even though you've had the loan for 24 months, interest being charged every month for 24 months, you're only making really 21 payments, because you're making the first payment in the fourth month. So you've lost the 24 minus 3, which is only 21 repayments. That's why once we get down to this point, we're going to see that our R is going to be 21. So take it under advisement. Set up your patterns every time. So after 24 months, again, it's going to be what's left to repay is 0. So A24 is equal to 0. And that's going to be equal to that statement. And again, I've just manipulated around, subtracted the values with the m on this side. Added it on both sides, so it becomes positive. Factorise the m, and I can see that I'm going to have a geometric progression. First term is 1, and then it's going up by 1.015, so that's our common ratio. But again, there's 21 terms in this series, not 24. Put 24 in, you're not going to get it right. So we apply the geometric, as sum of a geometric series, a r power of n minus 1 over r minus 1. And then to get n by itself, we've just multiplied by its reciprocal, so that's why it's just been turned upside down to multiply by the 3,000 times 1.015 to the power of 24. Do the calculation, and it ends up being 175.25, which sounds about right for in making 21 repayments of that. So be really careful. Again, questions are going to be thrown in that just slightly different, and there's going to be problems there. So in this one, Lee wishes to set aside a certain amount of money at the beginning of each year for 10 years at 6% per annum interest. She wants to have $50,000 at the end of 10 years. So this time, this is not a loan repayment type situation. This is more of an annuity type situation, but at the end we want $50,000. So you've got to work with what we've got, and we don't know what the amount we're going to be putting in. So we've got to manipulate it again to do that. So, but again, what happens? We put in an amount, it gains interest for the end of 1 month. For the second month, we add another, make another payment, and it gains interest. So we end up getting expression in this form. So, sorry, I'm saying month, I should be saying year. So, because 6% interest per year. So at the end of 10 years, she's made 10 payments in there. And the first amount's had interest gain for 10 years, the second amount for 9 years, and so on, till the last amount's only gained 1 year of interest. That what we want is A10 now to be equal to 50,000. So again, we look at what we've got, we can factorise them out, and what we've got left is going to form a geometric progression. A being 1.06, R being 1.06, and 10 terms. So there's your A, the power of n, minus 1 over R minus 1. Again, what we do is multiply both sides by the reciprocal to get our 50,000 times the reciprocal there. Put the amount in, and that's how much she needs to put in at the start of each year for 10 years to get $50,000.